All right, so this review is to go over all the stuff that we've done with normal distribution up to this point. So, the first thing we talked about when we did normal distribution was our empirical rule, which says that from our mean, if we're one standard deviation away, 68% of our data lives within one standard deviation from the mean. And then from 2 standard deviations from the mean would be 95%. And then 3 standard deviations would be 99.7%. So we can figure out percentages based off of this empirical rule. So if we look at this example, this normal distribution represents a batting average of 100 professional baseball players. The mean is 0.5 with a 0.14 standard deviation. So the first thing we'll figure out is kind of where each of our standard deviations lie. So the mean goes in the middle, and then I'm just going to add 0.14 going this way each time. So 0.5 plus 0.14 would give me 6.64. I'll add 0.14 again, so I get 0.78, and 0.14 again, and I get 0.92. And then I'll subtract 0.14 going this way, so I would get 0.36, 0.22, and 0.08. So this represents all of our mean, and then 1 standard deviation, 2, and 3 standard deviations from the mean. So what percentage of baseball players are between 0.8 and 0.92? So on both sides, we're 3 standard deviations away. So our empirical rule is that this is 99.7. What percent of players are between 0.2 and 0.78? So again, we're 2 standard deviations away. So then I'm at, my empirical rule is 95%. And then 0.36 and 0.64 are 1 standard deviation away. So the empirical rule says 68%. So those ones are easy because we're the same number of standard deviations away on both sides. So now let's look at some that are a little more complicated than that. So what percent are between 0.2 and 0.64? So I'm here and 0.64 is here. So I'm looking for this shaded area here. So on this side, right, here's my mean. On this side of the mean, I'm 2 standard deviations away. On this side of the mean, I'm only 1 standard deviation away. So I treat this as separate halves. So if I look at this right half, right, I'm 2 standard deviations away. So my empirical rule is 95%, but I'm only looking at half of my picture. So we'll take the 95% and divide by 2. And then if I look at this half of my graph, I'm 1 standard deviation away. So my empirical rule is 68%, but again, I'm only looking at half the picture, half of that. So I would do 68 divided by 2. So to get that full shaded region, I would have to do 95 divided by 2 plus 68 divided by 2. And that would tell me all of this put together. So 95 divided by 2 plus 68 divided by 2 would give me 76.5%. All right, so if we look at our next one, the next one says what percentage of players are between 0.8 and 0.78. So on this side, I'm 3 standard deviations away. 1, 2, 3, because I want this entire shaded region. And then on this side at 0.78, I'm only 2 standard deviations away. 1, 2. So again, I'm uneven. I'm 3 on this side and 2 on this side. So I can't just follow it one empirical rule. So how I like to do this, and there's multiple ways to do this, but what I do is I cut it in half. So looking at this side, I'm 3 standard deviations away. So my 0.997 applies to this half, but only half of it. So I take my 99.7 and divide by 2. Then when I look at this half, I'm 2 standard deviations away. So my empirical rule for 2 standard deviations is 95%. But again, I'm only looking at half of that, so I divide by 2. So then if I take my 99.7 and divide by 2 and add it to my 95 and divide by 2, I end up with 97.35 as my area of both of those added together. All right, so then what percent are between 0.5 and 0.92? So now between 0.5 is right there in the middle and 0.92. So really I'm just looking at this half of my graph that's 3 standard deviations away. So I'm looking at my 3 standard deviations, but only half of it. I didn't go all the way to the other end. I just did half of it. So that would just be my 99.7 divided by 2. So then 99.7 divided by 2 would give me 48.85. All right, what percent of players are averaging more than 0.22? So here's 0.22, and I want to know everything greater than that, including the stuff past my 3 standard deviations. I know that it looks like the graph ends at 3 standard deviations, but really this graph keeps going past 3 standard deviations, because 3 standard deviations is only 99.7. So there's still a little bit left at the end of this graph. But I know that if my mean is right here, this half of my graph makes up 50%. Right? I'd have 50 and 50. Right down the middle would split this in half. So I know that this half is 50, so then I just have to figure out from 0.22 to 0.5 what that area would be. So since I'm 2 standard deviations away, that would be 95 divided by 2. So I'll take 95 divided by 2, and I'll add that 50% to it. So then I end up with 97.5. And then what percent of players have an average of less than 0.64? So again, if we look at our graph, now I'm here at 0.64 and I want every value less than that. So I want this whole shaded region here. So again, when I split, I'm going all the way to the end of this graph, not just 0.08, but all the way to the end of this graph. So when I talk about my mean, this makes up 50%, because that's 50% of my graph, half of the graph. So then I just need to figure out what this piece is to make up the whole picture. So if I look, I'm 1 standard deviation away, but just on half of my graph. So if I do 68 divided by 2, that will tell me this area, which is 34, and then I add it to my 50. So my 68 divided by 2 plus 50 would be 34 plus 50, which is 84%. All right, so that was our empirical rule. That was how with certain standard deviations, we could figure out the area underneath our curve. So the next thing that we did in our normal distribution was we started talking about z-scores. Z-scores allow us to take any type of data and put it on a standard normal curve. So that means it's taking the data and it's giving it a mean of 0 and a standard deviation of 1. So it doesn't matter what the mean or the standard deviation used to be. By finding the z-score, it's putting it on this standard normal curve. So to do that, to find our z-score, we take our x value, we subtract it from the mean, and we divide it by its standard deviation. So if we're looking at our examples here for number 9, I would take 62, subtract my mean, which is 56, and divide by 4.5. So 62 minus 56 divided by 4.5 would give me a z-score of 1.33 repeating. So that would be something like right here if we were putting it on our standard normal curve. So then if we look at our next one, same thing, we're finding the z-score. So I'll take my x value, subtract it from my mean, and divide it from my standard deviation. So 112 minus 142 divided by 27 would give me negative 1.1 repeating. So that would be on this side. So it just allowed us to take data with different means and standard deviations and put them on the same curve where we can actually compare them to each other. So for example, if we look at number 11 on here, Anthony and Reagan took a test in different history classes. Anthony got a 70 when the mean was 62 and the standard deviation was 6. Reagan got a 75 when the mean was 65 and the standard deviation was 8. Who actually performed better on their test? So we're taking two different data sets and we're putting them on the same standard normal curve, just like we did above. Positive 2 and 3. Very ugly too. Okay, so I'm going to take Anthony first. So his test score, he got a 70 when the mean was 62 and the standard deviation was 6. So when we compute his z-score, 70 minus 62 divided by 6, we get 1.3 repeating. So that means he falls right about there. And then if we look at Reagan's score, Reagan got a 75 when the mean was 65 and the standard deviation was 8. So 75 minus 65 divided by 8 would give us a 1.25. So that'd actually be closer to 1 than Anthony. So if we think about this, right, the mean would be where the average amount of people are doing. So you want to be farther from the mean because that means you did better than most people. So since Anthony, right, Anthony's z-score was higher, that means Anthony did better on his test. Wow, Anthony. His score was relatively higher, farther from the mean, which means he did better on the test than Reagan did. And that's the good thing about z-scores, is allowing us to put things on the same scale in order to compare. All right, so then the last piece of normal distribution that we've done so far is when we were looking at a standard normal curve, finding the probability or the area under the curve for any values. It didn't have to be within its standard deviations to use our empirical rule. We can use any value with our calculator. So if I look at this first one, and all of these have a mean of 0 and a standard deviation of 1 because there are standard normal curves. All right, so the first one wants greater than negative 2.29. So that would be somewhere over here. And if I want greater than, that means I want all of this area underneath my curve. So then I'm starting at negative 2.29 and I'm going to the very end of this graph. So remember we talked about last class, the very end of the graph this way is positive 1e to the 99. The very end of the graph this way is negative 1e to the 99. So when I use my calculator, I'm doing a normal CDF. My lower bound here, I'm starting is at negative 2.29. I'm going all the way to the end of the graph, so 1e to the 99. And then my mean is 0 and my standard deviation is 1. So to do that on my calculator, we go second vars, normal CDF. My lower bound is negative 2.29. My upper bound is 1e to the 99. My mean is 0. My standard deviation is 1. So then I have that all ready for me. If I hit enter, it tells me that area of that shaded region is 0.9890 when I round that. Because that 8 would round that up and that up. So we get 8990. Okay, so we're going to do the same thing for the next two. So between 0.76, so that would be between 0 and 1, and 2.34. So I'm looking for this shaded region here. So again, because we're looking for the area under our curve, we're doing a normal CDF. Our lower bound is how far to the left we go, so that's our 0.76. To the right, we went 2.34. Our mean is 0. Our standard deviation is 1. So going back to our calculator, we hit second, vars, normal CDF. Our lower bound is 0.76. Our upper bound was 2.34. Mean is 0. Standard deviation is 1. So then when I hit calculate, the area of that shaded region is 0.2140 when I round that. Okay, so then the last one we have to do, if I'm less than negative 0.5, so negative 0.47, my bad. So that'd be right about there. And this doesn't have to be, like, where you draw this line, it doesn't have to be perfect, but it's negative, so it should be on the left side of 0. And then I'm shading everything going this way. So again, when I shade all the way to this end, we use negative 1e to the 99 to represent shading all the way to the far left. So I'll do my normal CDF. This one's going, the lower bound now is negative 1e to the 99. It stops at negative 0.47. My mean is 0. My standard deviation is 1. So second vars, go down to normal CDF. So now my lower is negative 1, and then to get to E, we'll just use this E here. So if we hit second and then the division, we get our E, 99, and then negative 0.47. And the area under that part of our curve is 0.3192. All right, so that is the review that is what we've done so far in our normal distribution before we move on with more today.